Hi kiddos, welcome back to more calculus via video. So you practiced finding limits from graphs and coming at them from lefts and rights. And today we're going to do what's called limits analytically. And all that means is we're going to rely on your algebra skills. Analytical just means algebra. So we're going to do all the fun stuff that you love to do, like factor or FOIL and multiply by conjugates and combine common denominators, and all the stuff that you learned back in Algebra 2 that you haven't used much is coming today. So we'll start off slow to make sure you remember what numbers are and go from there. So let's take a limit as goes to 3 of this. So here's what's going to happen to you. I'm about to make you very smart, and you're going to learn all of these wonderful things you can do with limits and quick tricks for taking them, and you're going to practice your algebra, and then you're going to forget the basics. So here's the basics. When you take the limit, step 1, regardless of how much you know, is to plug in. You're going to plug in the number that x is approaching and see what happens to your limit. Because for this limit, if you plug in 3, x squared minus 9 becomes 0, plus 3 is 6. 0 divided by 0, next question. And they can be that fast if you're paying attention. So let's do a different one. Similar, but different. Let's go to 1 for this guy. Now when I plug in, if I plug in 1 to the numerator, 1 cubed minus 1 is 0, 1 minus 1 is also 0. This is something called an indeterminate form. 0 divided by 0 is indeterminate. There are 7 indeterminate forms. This is the first of 7. Indeterminate means keep looking. It doesn't mean does not exist. It doesn't mean infinity. I guess I should say it could mean the answer is infinity. It could mean the answer is 0, but you have no idea. You have to keep looking. So here are your options for keep looking. I'm going to call them step 2. Step 2 is algebra. And we're going to go through all those things that I mentioned earlier, like factoring. Do you remember how to factor difference of cubes? Maybe, maybe not. Maybe I should go make you look it up. I'm just going to throw mine down here. I do difference of cubes, even though I don't use it much. This is going to be minus 1 and then squared plus this. So I will go make you look those up. Go look up your 2 factoring cubes. So factoring difference of cubes and factoring sums of cubes, because you're gonna use them and you're gonna need to know them quickly, or at least have them somewhere where you can flip to them really fast. So get those in your notes. All right. So after you factor, the beautiful thing that happens is these reduce to 1 and they're gone forever. And then you're back to step 1. So after you've done something, after you've reduced it, cleaned it in some way, you're back to step 1. And step 1 says plug in. 1 plus 1 plus 1 is 3. So looky there. 0 divided by 0 for this question equals 3. And that's what we're doing today. Let's try this. So first glance, I don't know. Step 1, plug in. Let's see what happens. Root 4 minus 2 is 0. Uh-oh. 0 divided by 0. No big deal. I'm just going to keep looking. So algebra. Right now, the only algebra I have in my list is to factor. Do you see a way this can factor? Are you feeling clever this morning, afternoon, midnight, whatever time you're watching this? If you are feeling clever, you might see a difference in squares in your denominator. I can make this a root x plus 2 and a root x minus 2. And then my root x minus 2 is reduced to 1. And I'm left with 1 over 4. If you're not feeling clever, that's okay. I'll show you another way to deal with square roots in a second. All right, so that's how we would handle cancels. Remember, there's lots of different kinds of factoring. Don't forget about DCF factoring, factoring by grouping, I just did difference of squares and difference of cubes, but the normal trinomial factoring, all that stuff is going to come back. And if you need practice with it, let me know. I will get you a ton. All right, let's do a different kind of algebra. You spent time in Algebra 2 cleaning these monsters up. So you have done this kind of cleaning before. It's just you've never had to write limit on the front end of it. So I hope that gives you some comfort because it should look a little bit familiar. So the next kind of algebra we're going to talk about is common denominator, which is a little bit boring, but once you clean it up, everything goes away real quick. So you're not actually going to do anything to it. You're just going to clean it. All right. I'm going to say it once. I'm going to say it 1,000 times. We all know that a plus b squared is not a squared plus b squared. Everybody knows that. And if I write it the other way, you still know it. So if I flippy do these guys around, you still know that. But something happens to your tiny little brains when you write limit on the front and you think that all these brand new rules still apply to these questions, and they don't. So don't do it. What I'm trying to say is you can't combine these two things. You can't write this as 2 plus x minus 2 to the negative 1. You can't do that. That's the same thing that we wrote over there. So don't do it. Okay. Raising to the negative 1 is the same as reciprocating. So this is going to be 1 over 2x minus 1 over 2, and that all over. So when I say common denominator, I mean up here. So we're going to find a common denominator for our numerator. I haven't taken a limit, so I have to keep writing limit. AP is very, very strict on notation, so make sure you're careful with the notation. This guy's going to get multiplied by 2 plus x, 2 plus x. This guy's going to get multiplied by 2 over 2. And now I have a mess on top of 2 minus, don't lose the negative, 2 plus x, all over 2 times 2 plus x. And then it's still just over x. I'm going to put an over 1 so that you can see your complex fraction there. Then everything happens really quickly. Things are gonna clean so fast. So 2 minus 2 is goodbye. Don't lose the negative in front of your x. And I have a complex fraction, which means I need to divide. So I'm going to do some keep, change, flip fun. So I have a negative x over 2 times 2 plus x. X over 1 flips the 1 over x and turns into multiply. And now I can reduce again. X and x reduce, and I'm done. Because now when I go back to plug in, I just have a negative 1 on top, and that's not scary. 2 times 2 is... That was fun. I had fun. I hope you had fun. I hope you're writing while you do these. Although I write fast. I know that. Sorry. Feel free to pause. All right. One more kind of algebra to talk about. I'm going to put it up here in our list is a conjugate. I know you've heard the word conjugate. It might have been a while since you've written a conjugate and think of what a conjugate is. Let me show you a question. Maybe it'll pop in your brain. So here's a limit. We're going to go to 3. Now I have the square root of 25 minus x squared. Then, excuse me. So if I step 1 plug in, 25 minus 9 is 16. Square root is 4 minus 4. 0 over 0. That's fine. Not scared. 0 over 0 means keep looking. I'm going to keep looking. All right. A conjugate. Do you remember back in the day when Dr. Pickle lied to you, one of the many times she's lied to you, and she told you that you had to clean up these fractions with radicals in the denominator and you had to rationalize them? And so you went and multiplied by root 2 over root 2. Or you had something like this, and she told you you had to rationalize denominators. Well, here's the big joke. Nobody cares if you rationalize denominators. That's not actually a thing that anybody cares about. AP test doesn't care. ACT might care, but those don't exist anymore. So the reason you are taught how to rationalize denominators is so that when you encounter a question like this, conjugates pop in your head and you're comfortable using them. So I'm going to multiply conjugate. Conjugate means you take the first term and write it. You take the other term and write it, and then you switch the sign in between. So the minus becomes a plus. Because what you're doing is you're turning it into a difference of squares, which is going to eliminate the radical, which is the goal. Don't want a radical because they're complicated and messy, and I don't like writing them. Okay, here's another trick for you. Not a trick. Here's another rule for you. Do not multiply out denominators. Put parentheses around them so that you know that they're being multiplied as terms. And you don't mess up your answer when you go to plug in again, but don't multiply them out. Hardly ever should you multiply out a denominator. The numerator now, if I throw parentheses around this so you can see your foiling, first times first is just going to make 5 minus x squared divided that radical. And then I have 4 of them, minus 4 of them cancels, minus 16 to n. And again, things happen very quickly after that first step. So 25 minus 16 turns this into negative x squared plus 9. I will factor a negative out for you, even though this is not how I would normally think about this, but you people like it. And then I have plus 3 minus 3 squares. X minus 3 reduced to 1, and you're finished. So as you're finishing, this is your numerator now, and your denominator is just this thing. Got to write neatly so you don't lose stuff. You've got a negative 3 plus 3 is 6. You've got, oh no, 25, 9, 16, 4, 4, 8, and then a negative 3 because of course we're going to reduce our fraction. There you go, friends. There's all of your options for, that's not true. There's the majority of your options for algebra. Anything is fair game as long as it's legitimate algebra. Right, so I'm going to give you kind of a practice question down here to see what you do. There are a couple ways to go about this. Look more intimidating than it actually is. Just want to see what your brains think. So I would like for you to pause the video and take that limit. If you have now unpaused the video because you need a hint, here are your two options. You can expand that numerator or you can factor. Here's what I mean. Like we all know, and you would never, we're going to joke about it so much. It's so funny. You would never do this. That's not true. We all know that. But when I say expand, you could sit here and do 2 plus h times 2 plus h times 2 plus h. And I mean, I know you're lazy and you don't want to, but it's not terrible. It's not the worst thing that you would have to do. So you could multiply those out and then throw the rest of it in there. Do the minus 8, divide by h. It would go pretty quick. Your factor option is to treat this as a difference of cubes, where this is like a cubed minus your b cubed. And I'm going to write this one out because it kind of messes with your brain a little bit. I'm going to put the limit back into it too. So if I factor the numerator as a difference of cubes, I would have 2 plus h minus 2. You keep the same sign. And then you square the first, so 2 plus h squared. Then you multiply them together. And then you square the last. And that's what it would look like. And then it's still all over h. And I know, like, it looks worse. Why would you do that? Who are you helping right now? But watch how quick. 2 minus 2 is gone. H divided by h is gone. And you're finished. So regardless of which method you used here, you should get 12 as your limit answer. I hope that went well for you. Let me know if it did or did not. And I will see you soon.